Right, hello Year 8. So today what we're going to do is look at how we developed the periodic table. Now you've seen the periodic table probably in science classrooms all the time, so you know what it looks like, but hopefully we're going to look today and understand exactly how we came up with the modern periodic table. So what we already know. Now what I did was I did this lesson with the other group the other day, so actually I left up what they already knew. So I'll go through this, and what I'd like to do is do something similar. So like a spider diagram in the middle with what I already know. Now you can add some of these things because, be completely honest, you should know most of these. So in the periodic table, you find the metals, you find noble gases, you find non-metals, and there are reactive metals. Okay, so those are some of the things we should already know. The numbers go up in order or are in order. There is atomic mass, which is protons and neutrons combined, which again we know about. It's a table of all the known elements. So everything, all matter that we know about is on, in some way, the periodic table. It's arranged by atomic number. There are 8 groups. Most of the things in the periodic table are actually solid. Some are liquid at room temperature. Okay, now these are some of the things hopefully you should already know, or what the other group knew. But anything you know about the periodic table, I'd like to add to this. So the first thing to do is copy some of these up, but then pause it, and anything you already know about the periodic table, please add that. Okay, so pause the video and do that now, please. Okay, so today, all of you should be able to explain what the periodic table shows you and identify a few basic patterns. Most of you will be able to describe the patterns in the periodic table and link this to how it was discovered. And a few of you will be able to explain in detail all the relevant patterns on the periodic table. And that will come as a result of the research. So a few key words: element. The periodic table is just the elements. No, it's not compounds. So water is not on the periodic table, and I'll explain why in a minute. Neither is carbon dioxide. To do with atomic number, something to do there. Atomic mass, partly relevant, but not really. Protons, neutrons, electrons, okay, those are all relevant. Reactivity and pattern, okay. So what I'm going to do is I'm going to talk you through a few key factors of the periodic table. So in assignments, there is a copy of the periodic table which looks like this. Apologies if I can't quite get that all of it in, but just quickly show you. So this is the periodic table. Okay, I'm just going to talk you through a few of the key factors about the periodic table. So the first thing is its arrangement. Okay, so essentially it follows this little number at the bottom here. So you see there are 2 numbers. The bottom one is the atomic number, which is the number of protons. And as you can see, it's arranged like this. If we follow it, we go across 1, 2, and down 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on. So essentially, the periodic table is arranged by atomic number. So essentially, it goes up by 1 as you go along. Okay, so what I'd like to do, that's one of the key points I'd like you to sort of bullet point in your book. Or if you want, you can bullet point it on the back of the periodic table because you're going to print this off. Okay, so firstly, as you go along the periodic table, the atomic number goes up by 1. And you can see that follows throughout, all the way through. Okay, 20, 21, 22, 23, it goes up and up, even as you get down to the really big ones like this. Okay, right, so the next thing you might have noticed, there are these numbers at the top in Roman numerals and numbers going along the sides. Okay, so what we've just described is going along like that, the atomic number going up. So the atomic number we would say goes up as you go along the periods. So these numbers at the side, so that's period number 1, period 2, period 3, period 4. The atomic number goes up by 1 as you go along the period. And that's how the table got its name, the periodic table. But there are also the groups. Now, this is where it starts getting a little bit more complicated, okay? So the next point is you've got group 1, 2, 3, 4, 5, 6, 7, and this group is sometimes called group 0 or group 0. Group 8, depending on which periodic table you look at. Okay, now, essentially what happens is this. Why are there 8 groups? Okay, because why, for example, isn't there just a list? For example, we get to 10 here. Why doesn't it just go 11, 12, 13? Why does it then go back here, 11, 12, and then we get to 18? Why does it go back to 19 down here? And then we get to 36 over here. Why does it go to 37 here? Why not just continue on as an endless list? Well, the reason is quite simple, okay? When scientists were first looking into the periodic table, they started to group them in things they had in common. So, for example, they realized that lithium and sodium and potassium and rubidium, and this one here at the bottom, cesium and then francium, they all had very, very similar properties, okay? They were all very, very, very reactive with water and acids. So what they did was they decided to put all of the elements which were very similar together. And same over this side, they noticed that these elements, so helium, neon, argon, krypton, xenon, and radon, they all had very, very similar properties as well. These were all very, very unreactive, okay? And so they are known as the noble gases because they're noble, they don't react to things like in a posh voice, okay? But they also noticed things like this, for example, carbon, silicon, and I can't remember what those, germanium, I think that is. Those all have similar properties too, so they were all put in group 4 there. So essentially, the reason they repeat and go back this way is because they have similar properties. Now, so everything in group 1 kind of does the same thing. Everything in group 2 kind of does the same thing. The difference is that these elements, as you can see, get heavier and heavier. So look at their mass. 9, 24, 40, 88, 137, 226. They get heavier and heavier as you go down. Okay, so the next point you could make is this. Elements which are in the same group have similar properties. So that'd be your next point. So once again, quickly pause the video and write that down. Elements which are in the same group have similar properties. They all kind of do the same thing. All right? Now, here where it comes really interesting. Why do they do the same thing? Well, it all goes back to those electrons. Okay, now I'm going to use group 1 as my example. Okay, so lithium has got 3 electrons. The first 2 in the first shell and then 1 in its outermost shell. Okay, now if we count along, hopefully you remember that you can have up to 8 electrons in that shell. But this has got 1 electron in its outer shell. This would have 2. This would have 3, 4, 5, 6, 7, 8 full outer shell. And then sodium, its outer electron would be on the next shell. So it would have 1 in its outermost shell. 2, then 3, 4, 5, 6, 7, 8. That's full. 19 electrons. So therefore, 2, add 8, and then that is 18, and 19, that 1 electron in the outer shell. So the thing that these all have in common is they all have 1 electron in their outer shell, and that's why they all kind of do the same thing, because they all have that 1 electron in the outer shell. These ones all do the same kind of thing because they all have 2 electrons in their outer shell. These ones, group 3 all have 3 electrons in their outer shell, group 4 all have 4, and these ones all have full outer shells. They all have, well, 2 in this case, but 8 electrons in their outer shell, and that's why they don't react, because their electron shells are full, they're happy, they're stable. Okay, so that the reason we get this repeating every 8 is 1, 2, 3, 4, 5, 6, 7, 8 is because the electron shell becomes full, you go back to the next electron shell. Okay, so it repeats every 8. So what we tend to notice about the periodic table, and I'm just going to go quickly back, because what happens to reactivities of metals as you go along the periods? So as you go down, as you go along the period backwards, the metals get more and more reactive. Okay, so if you remember, I said the periods, the atomic number goes up as you go along the periods. But if you go backwards along the periods this way, they become more reactive. They also, with metals, they get more reactive as you go down. So francium down here is the most reactive metal that there is. In fact, there's only probably a few micrograms of this stuff in the Earth's crust, and if you could get a few micrograms of it and concentrate it and put it all together, if you drop that in water, it would cause a very large explosion because it's so reactive. Okay, now metals actually, sorry, that's for metals. So can you, when you print off your periodic table, add little arrows like this? So more reactive going down the groups and more reactive going backwards along the periods. Now, with non-metals, the exact opposite is true. They get more reactive as they go right along the periods and as they go up the group. And so therefore, the most reactive of the non-metals, which is just this little corner here, is in fact fluorine. Now you might say, well, hold on a minute, there's these ones over here, they're more to the right. Remember, the noble gases have full outer shells, so they don't react at all. So if we just go back, that group, they don't react at all. Fluorine is the most reactive non-metal. Remember, this is just the non-metals in green. And francium is the most reactive metal. Okay, so one more task for you. You might have noticed something else which doesn't seem to quite fit. Okay, all these elements in the middle, these are all metals, and they don't have a group. Look, they're not in a group. They're not neatly lined up in a group. So these don't follow the pattern exactly. They follow some of the patterns. So they follow the pattern of the atomic number going up, but they don't follow the pattern of reactivity because of the electrons in their outer shell. And so we call this middle section here the transition elements or the transition metals. Okay, so from here, from the edge of group 2 to the edge of group 3, these are all called transition metals. And there are a few things in here you'll be familiar with: iron, nickel, copper, zinc, kind of metals that you've come across before in chemistry. Okay, right, so your first task is this. What I would like you to do is print off a copy of the periodic table. This is in assignments, and do a quick internet search, and I'd like to shade in the following. I'd like you to shade in the reactive metals in one color, transition metals in another color, non-metals in another color, and noble gases in a fourth color. Okay, so reactive metals, transition metals, non-metals, noble gases. Okay, so pause the video and do that now, please. If you're having trouble printing this off, what I would suggest you do is probably a bit of a pain to copy it up. So draw out the approximate outline and maybe just the element symbols. So that's just the little letters. Don't bother with the names and the numbers, atomic number and the atomic mass, otherwise you'll be there all day. But do make sure you know which group they are in. So that's groups going down, 1, 2, make sure they line up properly, and the periods going across. Now, if you want, you can also find out what this separate section is here at the bottom and colour those in separately as well. And if you're feeling really clever, okay, maybe do a slightly different shade for the elements that are liquid at room temperature. There are not very many. Most of these are solid, but there are a couple of liquids in there at room temperature. See if you can find out which one those are, but that's just an extra challenge, okay? So pause the video and do that now. Print this off and colour it in. Should take about 5 or 6 minutes, okay? So remember, 1, reactive metals, where are they? 2, transition metals. 3rd colour, non-metals, and 4th colour, noble gases. Okay, off you go, please. Okay, welcome back. So what we're going to do today is a little bit of a research task. There's a short video I'd like to watch on YouTube, okay, and I'll put the link in assignments for you. And you're going to watch that. And also in assignments is some information about how the periodic table was identified and developed. We've known about most of the elements for a couple of 100 years, and scientists have been trying to organize them. And there were several mistakes made along the way, but ultimately many scientists contributed to the idea of the periodic table. So what I'd like to do is research and write about the development of the periodic table. So who was involved, what they did, why their discovery was so important, and it should be about a page, maybe to a page and a half long in your book, and you can include a few pictures and diagrams of the work. A couple of little key things. Think about the key people on the research notes in the assignments. I'd like you to do a bit of your own research on the internet, okay? And yeah, by all means, add a few pictures, okay? If you want, you can do it on paper and then upload it to assignments, or you can do it in your book, snap me a picture and upload that. Either is fine, okay? So I'll leave it open until the end of the day. So you've got until the end of the day to upload all your work. That's fine. And as always, I'll be online to help you. So good luck. But yes, how did we discover or develop the periodic table? Who were the key people involved and what did they discover and why? I'll give you a hint. The key person is based around the video clip. So you need to watch that before you do anything. Okay, good luck. Off you go.